Okay, let's talk about the transformations of sine functions. When we're looking at the equation of a sine function, our basic function is in black, the sine x. The a, k, d, and c are the transformations that happen to our basic function sine x. So, from this, we need to have in our table the basic coordinates for the sine x function, which are 0, 0, 91, 180, 0, 270, negative 1, and finally 360, 0. These are the basic coordinates for the sine function. On the other side of the transformations, in the transformation table, we will have this transformation happen all the time. 1 over k times x plus d, and for the y, it will be ay plus c. These are the transformations that will happen to the basic coordinates, and you would apply those transformations. This is don't forget that whatever's inside the brackets is opposite of what you see in the transformation table. So in the brackets of the equation is different from what you see in the table. The reason being is for k, the opposite of multiplied by k is multiplied by 1 over k. And for d, it says minus d over here, it will be plus d. And if it was plus d up here, the logic would be in here that it would be minus d. Alright, and the pink involves the outside, the y values involve the outside, and this is always true. This particular transformation part is always true. It never changes. So a sine curve looks as follows. It looks like a sideways S, and you would have all these points, 0, 0, 91, 180, 0, 270, negative 1, and 360, 0. So if we're looking at this in terms of a sine curve, you would have the y-axis, which would be here, and then you would have the x-axis, which we'll just move in a second. Okay, sorry, let's do that again. And we have it right here, and what we have here is, don't forget, that would be your basic sine function. A cosine, if you're in grade 11 university math, you learn about the cosine function. It looks like a sideways C. And in this case, again, you would have a basic axis, okay? The basic would look a lot like this. And what would happen is it would start at 1, 0, then it would go to 0, 0, 90, 0, negative 180, negative 1, 270, 0, and back to the top again. So again, what we're looking at here is the basic sine or cosine. In the 3M class, we're only focusing on the sine function. In the 3U, we're focusing on both the sine and the cosine. Alright, next part. So, let's talk about all those letters. What do those letters mean and what do they stand for? And now there's the if and the then. So, for example, the letter A. If A is less than 0, we would describe it as vertical reflection. That means A is negative. A is less than 0 means that A is negative. If it's a negative value right after the equal sign, it would imply that there is a vertical reflection. If A, the absolute of A, okay, absolute meaning the number, not the sign, is between 0 and 1, so the number, not the sign, is between 0 and 1, we would say that it vertically compresses. So there's a compression vertically by a factor of A. Not the sign, just the number. If the absolute of A is greater than 1, means that we would write vertically stretches by a factor of whatever the value is that's greater than 1. Alright, this A helps you determine the amplitude. So the amplitude comes from the letter A. The vertical stretch or compress affects the amplitude. So the amplitude is equal to the absolute value of A. Remember that amplitude is the radius, and the length of a radius is always positive. So you're always going to have an amplitude that's positive. Let's go to the next one. K. Remember, it's not K we're looking at, but 1 over K. What does that mean for us? Well, 1 over K is less than 0, means that it's negative. If 1 over K is negative, means that there is a horizontal reflection. And then the next part, if 1 over K is between 0 and 1, the number, not the sign, you would write a horizontal compression. It horizontally compresses by a factor of 1 over K. Again, the number, not the sign. If 1 over K is greater than 1, we would write horizontally stretches by a factor of 1 over K. Again, the number, not the sign. Next part is that the 1 over K helps us determine the period. The period, the length of one cycle of a sinusoidal function, whether it be sine or cosine only in grade 11 university, you'd find that the period is equal to 1 over K times 360. Again, it's only this number and not the sign, so we don't look at it in terms of positive or negative. The length of a cycle would be 1 over K times 360. 360 is a regular cycle. If you stretch or compress it based on 1 over K, then that will affect your period. All right, next one, D. That would be x minus d inside the brackets. If you see x minus d inside the brackets, we would say it translates right. If you see x plus d inside the brackets, it means that it translates left. Now again, that affects something of our graph. Now looking over here, we're looking at x minus d being in brackets or x plus d being inside the brackets. It translates right, so positive, a certain number of units, or translates left, negative, a certain number of units. Again, it depends on what's going on inside the bracket. This is known as the phase shift. It phase shifted either plus d units or minus d units, depending if it moves right or left. All right, C. C, that's the end, that's after everything. There's a plus C, and that means it translates up, or a minus C, which means that the graph translates down. So what happens here is this affects something called the vertical shift. The vertical shift moves up or down, so plus or minus. Later on, we're going to see that that vertical shift plays a major role in being able to determine some important key features about the graph. That's also known as the equation of the axis. So the equation of the axis would equal to y equals c and y equals negative c, but we'll see that in a little bit. Okay, first example. Example 1. Here's your equation, and I want you to graph this function. In order to graph this function, you also need to describe the transformation. What's very important here, whether you're in 3M or 3U, is that x cannot have any number attached to it. When we completed the square, we never had x have an attachment to it. When we looked at other functions, x never had an attachment to it, even in parabolas. So you must get rid of that so-called extra baggage. So we have that 1/2 that we must remove. So we do that by dividing everything inside that bracket by the 1/2, and this is what you get. From there, we can describe the transformations. The basic of this function is y equals sine x. Yes, you must write that. The a value is -3, which means it reflects vertically, and it has a stretch vertically by a factor of 3. The k value, the last part for a, you have to write here, is the amplitude. The amplitude is equal to 3. The k value is equal to 1/2. We don't want 1/2, we want the 1 over k value. So flip the 1/2 and it becomes 2. So 1 over k is equal to 2. How does that affect our function? Well, it stretches horizontally by a factor of 2. How does that affect our graph? Well, our period changes to be 2, which is 1 over k, times 360. 2 times 360 is 720 degrees. So now we've doubled this particular sine function from a basic sine function. So that's the next crucial piece. X minus d in our function says x minus 60 degrees. That means that the graph translates right 60 degrees. What does that mean in terms of the graph? Well, our graph has been shifted, phase shifted, plus 60 degrees. So you could write either right 60, so you can write either right 60 or you write plus 60. Either or is acceptable. The last part is c. c is equal to plus 1. So this function translates up 1. How does that affect the function? Well, it's called the vertical shift. The vertical shift is plus 1. From there, we can determine the equation of the axis. The equation of the axis is always the max plus the min divided by 2. In our case, the vertical shift moved everything, the entire horizontal line, remember it was the x-axis was our middle dividing line, it moved the whole graph up 1. Because of that, that also is our equation of the axis. So our c value is 1, and therefore our equation of the axis is y equals 1. So that's EA, is y equals 1. Alright, so here is our table. Y equals sine x. Our coordinates, 0, 0, 91, 180, 0, 270, negative 1, 360, and 0. In the other side of the transformation table, we will have, don't forget, this is your equation. And in that equation, we will have the following. 2x plus 60 degrees, that's found inside the brackets. Remember the 1 over k is 2x, and then plus 60 because it moved right 60 degrees. And then our y values is negative 3y plus 1. Plug in the coordinates and you will get the following values. Once you get that, you can then look at the table to check that you've got the right answers. For example, you will see that from 60 to 780 is the difference of 720 degrees. So that is equivalent to 1 period. You will also notice that the amplitude affects the equation of the axis. These zeros are the original equation of the axis, so these numbers here in the same spot as the zeros are the equation of the axis. So this one, and finally this one, all have the equation of the axis for the y value. Alright, on to the next video, folks.